And remember, systems of linear equations just meant you had two or more lines. And we were looking for where they met. And we talked about finding them on a graph or by substitution and elimination. Does everybody have a pencil? So you're ready? Yeah, do you have a pencil? She emailed me. Yes, Jetta?
You're not signing. You're literally not.
Thank you.
You're making sure.
That's fine. Alright, is there anyone else that was gone yesterday? Please. So you should have raised your hand when I was pulling out the papers and said, is there anyone else that was gone yesterday? Alright, so when we are looking at a nonlinear systems, that just means at least one of them is not a line. So it's two or more equations in which at least one is not linear. Okay, so that means I might have like a line and a parabola, or I might have an exponential and a parabola, or an exponential and the line.
I only got 2 papers and like a whole
No, I sent them those back as well.
I got like a sticky note on 2 pieces of paper that I think I'm gonna hold. Nah, I forgot. They're at my house, or either at my house or my
Your
truck.
notes are with this. It's all paper clipped together. When we are looking for the solution, it's the point, we're looking for the point where both equations are equal. So it's where they touch if we're looking at the graphs. In terms of the graphs, it will depend on what kinds of things we're graphing, how many solutions we'll get. We know when we are graphing 2 lines, they could only meet once. But if you're graphing a line and a parabola, it could meet more than once. So we might just get a single answer. We might get multiple answers. Or it's possible that we won't have any at all. So that's what this is showing you. First one solution. You have a single point where those 2 graphs touch. Second one shows you cases where you have more than one solution because they meet multiple times. The last one shows you no solution because those graphs never meet. We are going to use Desmos to help us find those solutions. So everybody open up Desmos for me. So we've been using this the past couple days, and I'm going to type in the first equation, y equals negative 2x minus 1. And then my second equation, y equals x to the second minus 6x plus 3. Did everybody get those entered? So we are looking for the point where they touch. First of all, do we have a solution? Do these touch? Yes. Nice thing about Desmos is you can just click it and you're there. I am monitoring your screen, so do make sure that you are on Desmos and nothing else as we're going through this. So your solution is an ordered pair on this. So I can see it's 2, -5. If we were checking ourselves, what that means is when x is 2, y is -5, and that works for both. You could draw those graphs, so sometimes I might ask that you sketch the graphs. And we can certainly use Desmos to help us with that. It gives you everything that you need. I'm going to shrink this in so I can look at Desmos at the same time. So I want to show you a couple other features about Desmos. If you click one of your equations, so my cursor is on this first equation, and then if you hit this edit list, it gives you the option that you can create a table, and it will actually tell you points on that graph. So if I told you you had to draw the graph and you just had it on Desmos, you could ask Desmos to give you the points on it, and then you could plot those. So I can see for my line, I have points like -2, 3, -1, 1, 0, -1, 1, -3, 2, -5. And then you could use those points to sketch your graph. So if I told you you had to draw the graph, you can still use Desmos. I'm having a hard time. My slate needs to be recalibrated. It's not drawing straight lines for me today. But once you have them, you can get your line. And then the parabola, we could do the same thing. If you click next to it, and then if you go to your edit and select table, it gives you some points on that graph. Now, you certainly don't have to plot all of them, but you could put enough that you could support your answer. And we have 0, 3. 1, -2, 2, -5, and so you can see 2, -5 is the point where they meet. And so if I asked you to draw that graph, you can use Desmos to give yourself a few points and then sketch in the graph from there. You can certainly get more, but anytime you need a table of values, Desmos will give it to you. Okay, did everyone see how to get that table of values? Any questions about that? So sometimes on the EOC, they might ask you to sketch a point. You can use Desmos to get those points. So that might be handy if on all those graphing parabolas that we've done, if you are a person that struggles with putting them in the calculator and getting the right answer, you could use Desmos to get the actual table of values for it. All right. Number 2. So let's go ahead and use Desmos to get the solution here. If you want to quickly get rid of things, you can just hit the X and it deletes them out. So you could delete out everything that's there. And so if I type in my equations, we have y equals -x squared minus 4x plus 3, and x minus y equals 7. Sorry, -7. Right, you can always drag your screen so you can see it. How many points do these have where they meet? 2. So if you just click, you can get both of them. One is -4, 3. The second one is 1, 6. So I know my solutions here. If I asked you to draw the graphs, you can use Desmos to help you get some points. Or you could do your table of values yourself. We do know a couple points. -4, 3 is a point where they meet. -1, 6. But you can use Desmos to help you get more points on there. So I want you guys to do that and sketch those graphs. So you just click next to the one you want. If you hit settings and table, it will give you some points. So I have -2, 7, -1, 6. What was the next one on there? 0, 3. What else did it tell me? What's your next point?
1, -2.
Okay, so if I plot those, between those points and Desmos, I can get a pretty good idea. There's the first one. If you go to the second one, okay, if I click it, and then I can get my table for that one, then you can get those points as well. Okay, so you should be able to use Desmos to get some points so you could draw me a rough sketch. Plus we know the 2 points where they meet. So on the homework for these, I'm going to ask you to sketch some of them. It can be a rough sketch, you don't have to have it exact, we at least know the points where they meet, but you can use that table feature to get a couple more. Alright, let's just focus on using Desmos to solve the next few. So I'm going to delete out everything I have in here. My next equation, y equals 2x to the second plus 4x minus 1. Second one, y equals -x to the second plus 10x minus 24. All right, I have 2 parabolas here. What do you notice about those? They don't touch. If they don't touch, what is my solution? There's no solution. So on this one, no solution. Okay, I want you guys to try a couple. So 4, 5, and 6. I want you guys to graph them and get those solutions. Then we'll check it and see how we did. So in a system, you are just looking for where the 2 graphs touch each other. So in number 4, we have y equals -x to the second plus 4, and y equals x to the second minus 4x minus 2. And when I look at that, how many solutions are there? 2. So you should have -1, 3, and 3, -5. Did you guys all write down those 2 points? When I look at number 5, 4 times 3 halves to the x power. What type of equation did we call this yesterday? Exponential growth or decay? Growth, because it's rising. What kind of equation is the second one? Linear. It's decreasing linear. Okay. So those 2 meet. at 2, 9. Did you guys get that solution? Okay. If I asked you to draw the sketch on your graph, could you do that? You know the point 2, 9, they both touch. You can use the table to get a few more. So on a, not every homework question, but on a few of them, I am going to ask you to sketch a table. So you have to be able to get a few points on there. Can everybody handle that? Okay. And the last two, y equals negative x to the second, minus 8x minus 7, and y equals 18 times 1/3 to the x. So the first one, what kind of graph is this purple one here? What do we call it? It's a parabola, it's a quadratic, and this one is exponential decay. What do we notice about those? No solution because they don't touch. All right, can you guys handle these? Okay, so let me give you this handout.